what I just said. It's called logarithmic is the big word, but we shorten this with log, functions and their graphs. So today we're going to do the function part, and then on Monday we're going to do the graph part, and then on Tuesday we're going to do like properties of it. So we start with like what is a log. So a log can be rewritten in exponential function, and exponential function rewritten in log function. And basically what we do is we take that y equals log base a of x, so the little number that's subscript is called the base this time. And that base, think about it, is the base on the exponential function. Okay, so that base is the same number, letter, whatever it is. Okay, and I describe this, I've said this before, and I'm like, oh, it's going to get me in trouble one year. But logs are like high school relationships. They never stay together. Okay, not if you're dating someone and you're like, he's going to be my soulmate, she's going to be my soulmate. Not you. I'm not talking about your relationship. Your relationship will last forever and ever and ever. And I used to say like, oh, like I know my sister started dating her husband in high school and they've made it, but then they got divorced 2 years ago. So I legit mean most of them will never stay together. So the two numbers that are next to each other, whether they're in the log state or the exponential state, would never stay together. So when we're converting from one to the other, they always break apart. So if I have this expression here, what happens is the little number goes over and picks up that lonely little term, whether it's a number or it's a variable, it's going to pick it up because that person just left that first relationship and they're trying to pick up a new one. So they come over and they pick that up, and that becomes its exponent. So then the a comes over, picks up the y is now the exponent, and it drops off, leaving its former partner all by itself. So the base always goes over, picks up the other side, and then again drops off, leaving it by itself. So that's how to get from log into exponential. If we want to get it from exponential into log, the big number or the big variable that is raised to the exponent, this is my base. So it drops down at the bottom of the word log. Remember, they don't stay together, so the y gets kicked to the other side, and the x comes over on the side with the log to join that base. So the first thing we're going to learn to do is literally just convert from one to the other, but eventually you will get so good at this that you will know that by looking at this, you mean this expression. We will get so good at it that you could do, there's a lot of mental math involved in these, okay? But you've got to get to that point. So in the beginning, we will just convert back and forth. So that's what this is. Literally convert from log to exponential or exponential to log. So if I look at number 1, this is obviously in log, and I know that because log is there. The 2 comes over and picks up the 3, so it'd be 2 to the 3rd. It drops off, and it leaves the 8 by itself. They have to be true statements, so if they are all numbers, it still has to be true. Like 2 to the 3rd is 8, but a lot of times you're going to see these with variables, okay? So then 2, the 1/2 now comes over and picks up the -4, drops off, leaving the 16. And again, 1/2 to the -4 is 16. 3, the 10 comes over and picks up the 5, drops off, leaving the 100,000. Note that 10 to the 5th means there are 5 zeros. That's going to help us out a lot in the future. So 10 raised to whatever power, whatever that power is, that's how many zeros is my answer. Okay, now we're going exponential to log. How do I know that? That does not have the word log. That's the easiest way to see it, right? So what do I do with the 5? Where does it go? Good. So the 5 drops down, log 5, right? That's the base. 25 joins it, and the 2 gets bumped to the other side because they get separated. So then 5 would be log base 3. The one that has the exponent is always the base. So that's gone. 1 over 81 joins it, and the -4 gets bumped to the other side. No. most of the time when you see fractions, they're written like that, but you definitely don't need them. Yeah. How about 6? What would 6 be in exponential form? I mean in log form, sorry.
Log 3 over 4, 1 equals 0.
Good. Log base 3 over 4, 1 equals 0. So feedback from people and also like just what I've seen, it's easier a lot of times for people to go from log to exponential than exponential to log. So if you're ever feeling like unsure about your answer, like if I wanted to figure out, did I get this right? Just convert it back. If the 3/4 comes over and picks up the 0, drops off leaving the 1, do I get my question? And obviously, yeah, you do. Easy stuff, right? Yep. Okay, so here's some properties to remember. If you have log of any number, whatever the base is, and the big number is 1, it's always going to be 0. So log base 5 of 1 is 0. Log base 25 of 1 is 0. Log base 1/2 of 1 is 0. Because any number raised to the 0 power gives me an answer of 1, right? So the only way to get from 5 to a power to 1 is by raising it to the 0 power. The second property is if it's the same. So if the base and the big number are the same, my answer is 1. Because the only way to raise something to a power and keep it the same is to raise it to the first power. So this would be like log base 5 of 5, log 1/2 of a half, log 25. All of those are going to be 1 because the base on the log and the large part, the bigger number, are the same. Now it gets a little bit trickier, but kind of the similar concept is if the base and the large number are the same, but the large number has an exponent, then my answer is that exponent. So if I had log 5, base 5 of 5 to the second, the answer there is just 2. And think about why that happens. If I had log base 5 of 5 to the second equals x, let's do y since x is in that. And I wanted to convert this into exponential, how would it look? What picks up what? So if I want to convert that from log to exponential, what picks up what?
Which one's your base?
The base is 5, the bottom 5. So this is read as log base 5 of 5 to the second.
5 over 5
Wait, Miss Chris Weiser.
Yeah.
What even is log? Like, what is it?
It's it's hard to describe, but it's the inverse of an exponential function. That's all it is. So like if we switch the positions of the x and the y on an exponential function, we get a log. It's another way of rewriting an exponential function.
Okay.
Yeah. By definition, I would say that that's what it is, but how we use it, I think, is what you want to know. All right, so if I had log base 5 of 5 to the second equals y, this little 5 is going to come over and pick up the y. I'd end up with 5 to the y equals, it's going to drop off and leave me 5 to the second. Does that look familiar? That's my one-to-one property, right? My bases are now the same, and if my bases are the same, I can set my exponents equal to each other. So the solution here would just be 2. So we avoid all that with this. It's sort of a shortcut by identifying that the base on the log and the base on the exponential function are the same. We can literally cancel that all out, and the answer is the exponent.
But for the ones above that, can you cancel those out?
Sure, think about what this is. This is technically log base 5 of 5 to the first, right? So these would cancel, and my answer would be 1. Does that make sense?
Yeah.
Yeah, okay. All right, and then the last one is the one-to-one property applied to logs. If I have log of the same base on either side of the equal sign, I can literally disregard the logs and just set what's next to it equal to each other, just like I do with exponential. If I had a to the b power, let's say, equals a to the c power. Actually, I'll do the same variables. A to the x power and a to the y power. I would ignore the bases and I would set the exponents equal to each other. So you're doing the same exact thing, just with logs. So that's, we call this, it's still the one-to-one property. It's just that now we're applying it to logs. All right, so let's do some examples with those properties. Now I've got a variable, so it actually says solve for x here, right? So how do I convert this into, first of all, this is not one of the special things, right? It doesn't say it's log base 2 of 1. It doesn't say it's log base 2 of 2. That's not the same thing, right? So what's one thing I could do here? I can make 2 to the x. So 2 to the x would equal 32. Now what? So 32 is 2 and 16, 2 and 8, 2 and 4, 2 and 2. How many 2s you got? 1, 2, 3, 4, 5. So 2 to the x equals 2 to the 5th, which means x equals what? 5. Good. Another way to see that is to immediately see that 32 is 2 to the 5th, if your brain works that way. So I can say log base 2 of 2 to the 5th equals x, and then base and base on the exponential function are the same, right? I can cancel them out and keep the exponent. So 2 different ways to do it, both are right, and you have to figure out what your brain sees, okay? So whatever it is it sees, I would say go with your gut. If you are the type that's always going to convert it into exponential, then do it. If you can see that the base is actually a power of, or that the larger number can be raised to a power of the base, then you can simplify it there too. All right. Now what? 4 to the x equals 2. I could do 2 to the second raised to the x equals 2. And then it becomes 2 to the 2x equals, this would be 2 to the first, right? So 2x equals 1. And x equals 1/2. Also, something you could learn is if the larger number is the square root of the base, that means my exponent's a half. Remember, half is the same thing as a square root. What about 9?
0.
It's 0. So we could go long way around and say 3 to what power gives me 1. The only way to get a base of 1 is 0. Or you literally can learn that if whatever the base is, if that big number is 1, my answer is 0. People tend to like logs because they require less work sometimes. Just the mental math. People love mental math like logs because they can do a lot of it in their head. All right, now what? Ten to the x equals 1 over 100. Oh, you could, but you'll always still have that x. So you don't want to do that when there's an x in the exponent. You mean your cross multiply? We did that when there's a fraction with no exponents. Yeah. I can make 100, 1 over 100, 10 to the negative 2, and then x equals negative 2. So again, eventually we'll get so good that we'll look at this and we'll say, how do I get 10 to be 1 over 100? Well, I know I get 10 to 100 by squaring it, but it's got to move to the bottom, which means it's negative 2.
Can you go back to 9?
Sure. Audrey, you awake today? Yeah. Straight hair, Audrey looks sleepy. Like you look like your eyes are open, but you're not really awake.
I don't like this.
Madeline, let me know when you're good, okay?
I'm good.
Okay, you're welcome. All right, can we do this one quick? 0. Okay, if it didn't click, 6 comes over, picks up the x, 6 to the x equals 1. How do I get something to be the result of 1? And it's if it's 0. See if you could do this without converting to exponential. -3. So 5 comes over and picks up the x, equals 1 over 125. 125 has to go to the top and become a power of 5. So this would be 5 to the x equals 5 to the third, -3, and x would equal -3. Questions on any of those? Mm-hmm. All right, I'm gonna actually let you try. Do 13. Do 13 and 14. Let's see how far we can get on those. All right, what's 13? 7x equals 343. And then this is like weird number, right? So see if 7 goes into it. Does 7 go into 34? Yep, it goes, what? 49 times, right? And then 7 breaks apart, 7 and 7. So I'd get 7 to the x equals 7 to the third, so x equals 3. Then I go to 14. Now, x to the third equals 8 over 27. Did we figure this out?
2 over 3.
Good. So this is 2 to the third, and this is 3 to the third, which means it'd be 2/3 to the third power. So then what would be raised to the third power, x would be 2/3. How what?
I don't understand what it is.
So from here, you can actually just cube root this. So x to the third equals 8 over 27. To get rid of the third, I could cube root it, right? And x would equal the cube root of 8 over the cube root of 27. And the cube root of 8 is 2, and the cube root of 27 is 3. All right, now look at 15. 4 to the 5 over 2. So 4 to the 5 halves equals x. How do I convert 5 halves? It's the square root of 4 raised to the 5th. What's the square root of 4? 2. 2 to the 5th. 2, 2, 2, 2, 2. This is 4. This is 8. This is 16. 32. $16. 49 picks up the x, so 49 to the x equals the cube root of 7. What will be our common base? Like, what's our goal? 7. So how do I rewrite 49 to be 7 to the power? 7 squared raised to the x, so 7 to the 2x. And then the cube root of 7 becomes what? 7. What's the exponent if it's a cube root?
No, it's nothing. It's 1.
If it's a square root, the exponent becomes a half, right?
1/3.
So if it's a cube root, it's 1/3. Does that make sense?
Yes.
Yeah, okay. So this would be 7 to the 1/3. Now the bases are the same, so I focus just on the exponents. 2x equals 1/3. Divide both sides by 2, which is the same as multiplying by a half. And I get x equals 1/6. So when I'm looking like at your homework work, obviously something like the ones that fell on the last page, I expect that you could do some of that stuff in your head. But when I'm looking at stuff like this, there's definitely needs to be work done. All right, 17, 5 picks up the x. So 5 to the x equals 1 over 625. What do I want my common base to be? 5. So this can be 5 and 125, 5 and 25, 5 and 5, which means it'd be 5. So that would be to the fourth in the denominator, which means in the numerator, -4. And then x equals -4. All right, 18, 10, picks up the x, 0.001. That's not fun. I can make it 1 over 1,000. Because this would be hundredths, thousandths, right? I mean, that would be tenths, hundredths, thousandths. Now, so 10 to the x equals 1 over 1,000. How do I get 1,000 to the top? Negative.
1,000 to the negative.
Good. And how do I make it 10? -3. Remember the number on the x when it tells you how many zeros are in the power of 10. So this would be 10 to the x equals 10 to the -3. Then x equals -3.
I did before you did it, and I got x equals -3, but I just like, can't you just move this one?
Yeah, so whoever's in chem, hopefully, sees this, you can rewrite that in scientific notation, right?
Yeah.
Which is moving it 1, 2, 3 places. If I move it to the, if it's big and I'm moving it to the left, it's a positive exponent. If it's small like that and I'm moving it to the right, it's a negative exponent. So this is actually 10 to the x would equal 10 to the -3 because I had to move it again to the right, 1, 2, 3. And then x equals -3. So a lot of times when people are in chem or take chem, they see it that way, which is fine. Either way is good. Obviously that one's faster. Mm-hmm. Not everybody in chem sees it that way, but my 10-year-old was messing around with my calculator and he was multiplying in numbers, and he's like, what the heck is e to the -10? And I was like, oh, scientific notation. He's like, what is that? I said, just wait. Good, Madison? Okay. All right, last slide. Tell me what to do. It's not that bad. 1, I put the log on the other side. Ah! Switch it if it bothers you. Now what? 8 to the x. So, yep. So you freak out for no reason. You did the almost the exact same thing on the other side with a 3 in front. That's it.
It doesn't matter how it's placed. You just have to remember, like, what's your base, what's your
Exactly. Yep. Okay. Yay. Fun. Now I've got a log in the exponent. So let's, yeah.
Will x just always be the thing that's being squared?
No. So, not always.
You can have a number in front of either, right?
So this is actually exponential and log mixed together, right? So let's just focus on this side first, right? So pretend that this was not equal to x, right? Actually, let's go ahead. Let's set it equal to x. And let's say this is actually exponential. If it's exponential and I want to convert it to log, I make the big number the base. So I would write log base 3. This would go to the other side because that's the exponent. And the one on the other side comes over and joins it. So this itself was exponential, right? If I just focused on just that side, right? Do you see that that's exponential? Because the log is not on the bottom. But the exponent of this one had the log in it. So if this was just x equals 3 to the second, and I wanted to convert that to log, the 3 becomes the base, right? I would say log base 3. Remember, they don't stay together. So the x comes with the 3, and the 2 would fall to the other side. Do the same thing with this. It's more complicated, of course, but follow that same pattern. So take the base which is 3, put it to the bottom of the log. These don't stay together, so the log base 3x goes to the other side, and then the x goes with that first log because it gets a new partner. Now what's happening here?
You have 2 logs.
2 log base 3s. They have to be the same base, but if they are both the log base 3, I can actually disregard the logs and just set what's next to it equal to each other. So here's another shortcut. When the base, if an exponent is being raised to a log, if a base is being raised to a log, right? If the base of the exponential function matches the base of the log that's in the exponent, I can literally cancel them out and take what's next to the log in the exponent. So if this was 5 log base 5 of 10, my answer would be what? 10. So it looks a lot more complicated than it is, okay? Just think, if the base on the log is the same as the base in the exponential function, we cancel those and we keep the exponent. It's the same in just the reverse. Now it's an exponential function. So if the base in the exponential function is the same as the base in the log in its exponent, we literally can cancel through it and keep the what's next to it.
These are my favorite ones.
Oh, good.
I don't like
Yeah, I like these.
That's hysterical.
Are you being sarcastic or? No, I don't like.
Oh, that you like the easy mental math ones. Like, what's the answer here?
Yeah.
9.
Yeah, those are not fun.
Okay, the base here is the same as the base there, so I can cancel through it and keep it. If I rewrote that the long way around, 2 would be the base on the log. The x would join the 2. It would drop off, leaving the log base 2 of 9. And then the 1-to-1 property here says set just the x and the 9 equal to each other.
But like, where do you get the log on the left side from?
That's if you take, so this is technically, I know it has the word log in it, but that's an exponential expression. So if we were to go back to the very beginning when we were converting, we did log to exponential, and then we did exponential to log. This is exponential, and so I would be doing exponential to log. And when we did that, think that answer, that looked like 2 to the third equals x, right? That was our exponential in the beginning, right? We took the big number that's being raised to the power, we made it the base of a log. The 3 bumped to the other side, and the x joined the 2. So you're doing the same thing with this.
Okay.
This is the base, so we put the log in because we're converting it to log. That's the base on that. The one on the other side joins it, right, because they never stay together. And then the exponent, which happens to be a log this time, goes to the other side.
Okay.
Does that make sense? Okay. All right. What do I do? X to the negative 2 equals 25.
So what would you do?
What would I do?
You have 5 squared, but the base is different.
Right. I can't square root it because it's a negative 2, right? If I could, I would square root it plus or minus 5, right? How do I get rid of the negative? Put it in a fraction. 1 over x squared equals 25. Now what? I can cross multiply. I can put this over 1, and I get 1 equals 25x squared. Then what?
25. No, right?
Divide by 25. 1 over 25 equals x squared. Square root both sides. Plus and minus goes here. X equals plus and minus 1/5. Yeah.
From the beginning, I square rooted both sides and then like did the negative exponent.
Just be careful, make sure you remember the negative.
Yeah.
Yeah. I would say the other thing you can do here is I can say that 1 over x squared equals, well, I could have made it 1 over negative 25. I don't know if that's any easier. You could have done, no, I would have kept it the way it is. Otherwise, you lose the plus or minus. All right. 23? 4 to the 3 equals x. What's 4 to the third? 64. Easy peasy. Sometimes you don't know what order you're getting them in. You're like, holy crap, the end's hard. And then you're like, oh, all of a sudden there's one that's totally easy to me. That's how logs work. And then you'll get like in the easy part and you'll be like, what the heck's that? Yeah.
Now the first one was like backwards. Are we gonna have one like that on the test?
We haven't made your test yet.
Can we not?
There's going to be so much more put into this once by the time we get to your test. Yeah. All right. No. How do I get rid of a cube root?
Well, 4 to the 1/3.
Okay, this could be 4 to the x equals, and it would be 16, right, to the 1/3.
Oh, yes.
So instead of square rooting it, what do I do?
Make it 4 to the.
Make it 4 to the second. So just rewrite that base. Now 4 to the x equals 4 to the 2/3.
Can you, for like, do the opposite? Like 4 squared x equals 6. Oh, wait, never mind.
Wait, I have a question.
You would have to do 16 to the 1/2 if that's what you're thinking. Yeah, so an x is 2/3. You could do that though, like if you saw that this was 6, so 16 to the 1/2 is the same way as writing 4. And then it would be 16 to the 1/2 x equals 16 to the 1/3, 1/2 x equals 1/3 multiplied by 2. X is 2/3. So if your brain thought that way, that works. You have to make them both the same base.
I have a question.
Yeah?
How come for like 24, instead of square rooting 16, we put 4 to the second power, but then for 22, we have to square root 25?
Because the exponent was on the variable for 22.
Oh, so if it's on the variable, you have to square root it, and if it's on.
If it's on if they're both numbers, our goal is always to do the what base is 1 to 1. But if one's a variable and one's a number, we solve it. Does that make sense? Okay. All right, so that's what covers, like that's where your homework covers up to that point. Like I said, we're going to divide this section into 3 parts. On Monday, we'll go over the next part, which is actually graphing logs. Let me make sure. Is your homework published on Canvas? I can't remember if I published it and made it available or not. Hang on.
Yes.
It is published. I know it's on WebAssign. It is not published on. There it is. Okay. It's not bad.